Aloha everybody, this is Gigi from Kauai Community College. In this video, we are looking at applying the chain rule along with maybe the product rule or the quotient rule. If you are in my class, this is the set of the derivative cards for the chain rule, and this is problem number 11. So if you're not in my class, this is number 11 of the derivative card series. So make sure you look at the previous one before this one. All right, here we go. So number 11 said calculate the derivative of h of x is equal to 2e to the x plus e to the 2x all divided by 3. Now, why am I making a big deal about reading this problem? I want you to look at the problem, the function, and look at the structure of the function so that you can identify, do I use the quotient rule? Do I use the product rule? Do I use the chain rule? What am I doing here? Okay, so when looking at this here, we have a division problem, but it's divided by 3. So is it necessary that we use the quotient rule? And the answer is no, because dividing by 3 is a constant. So you really could rewrite that function at h of x is equal to 1/3. So that really is a constant multiplied to the function. And the function is 2e to the x plus e to the 2x, right? So then you will just have the 1/3 on the outside. You can pull that out when you are taking the derivative. Okay, so that would really, what I mean by that is the derivative of h of x is 1/3 multiplied by the derivative of this function here. The derivative of this function here, 2e to the x plus e to the 2x. And that's not a very good notation. I'm just going to go ahead and write d dx here. 1/3 multiplied to that derivative because you can pull out the constant. Okay, so that's one of the rules that we have. The derivative of a constant times a function is the constant times the derivative of the function. Now, when we say of the function, you have a sum right here, right? The first one is not that hard because it's just e to the x times 2, which the derivative of e to the x is itself. But this second term right here, e to the 2x is your inside function. So you have to apply the chain rule there. Okay, so what I really want you to practice when going over these derivatives is to look at the function and look at the structure of the function and realize what rules am I applying and how is this going to go, right? So here we go. The derivative of h of x is going to equal to, as we said, 1/3 will be out in the front, multiplied by the derivative of that sum. And the derivative of a sum is the sum of the derivative. So first, the derivative of 2e to the x is going to be 2e to the x itself, plus the derivative of e to the 2x. Well, the derivative of e to the 2x is a composite function, so the chain rule apply. The derivative of the outside function is e to the 2x multiplied by the derivative of the inside function, which is 2. All right, so that's the derivative, and you're like, okay, well, what can I do with that? Well, you can try to make it look nicer. And what do I mean by that? Each one of these have a 2. Each one of these has e to the x, so you could factor out 2e to the x, and then with the 1/3 in the front, that would be over 3, multiplied by what goes inside. If you take e to the 2x and factor it out, you just need to put a 1 right there. So when you multiply it back, you will have what you started, plus You factor out the 2, you factor out e to the x, so there is 1 e to the x left. Okay, so something that you may need to see is e to the 2x is the same as e to the x plus x, right? X plus x is 2x, right? And when do you add exponent? When you are multiplying. So really, e to the 2x is e to the x multiplied by e to the x, which is e to the x plus x is 2x. So when you factor 1 out, there is 1 left. Okay, so that's sort of a thing that you need to see, and that's just algebra right there. And so, yeah, so that is now your final answer.